Hey, today for Algebra 1, we're going to be continuing on in Chapter 8. We're going to be doing Lesson 8.3, which is on factoring trinomials. So when you factor a trinomial, really what you're doing, in the past we learned how to FOIL two binomials together, which would be to multiply them together. And we came out with an answer that was a trinomial that looked kind of like this up here. Now, when we're factoring a trinomial, that means we're going to start with this trinomial and we're going to get it back into this form. So before we learn how to factor the trinomial, I'm going to kind of show you backwards what we're trying to do in the end of this. So like we learned before, we can FOIL these two binomials together. Now I'm going to write this out the long way. We do x times x plus 3 times x plus 2 times x plus 2 times 3. Now, here, x times x, we're going to get x squared plus, we can rewrite this. 3 times x plus 2 times x can be rewritten as 3 plus 2 times x, and then we're still multiplying 2 times 3 at the end. So once we get this into its simplest form, we're going to have 3 plus 2, which is 5 times x, so 5x, plus 2 times 3, which gives us 6. So that means these two binomials would FOIL into this trinomial. So that's what we've done in the past. Like I said, today we're going to be working opposite. We're going to be given the trinomial to start with, and we have to get it back to the form of the two binomials that you would multiply in order to get it. Now, if you notice a pattern here, when you have a trinomial and you're factoring it, what we're trying to do is we're trying to figure out two numbers that add to whatever b is and that multiply to whatever c is. So this is for today when we have a trinomial with a coefficient of 1, meaning our x squared term only has a 1 in front of it. So again, if you see here, the two numbers right here, 2 and 3, they add to our middle term of the trinomial, which is 5, and they multiply to the c term of our trinomial, which is 6. 2 and 3, 2 plus 3 is 5, 2 times 3 is 6. So we'll get into some other examples here in just a second. So I'm going to teach you a method of factoring that is called the diamond method. Now, I'm just giving you a little intro to this method today because we don't necessarily have to use it when we only have a coefficient of 1, but it will come in handy to know once we get into some trinomials that have coefficients greater than 1. So in this case, what we do for the diamond method is we're going to draw an x in, called the diamond method. I'm not going to draw this every single time, but once you've got that x drawn in, we've got a diamond there. So when we do our diamond method, in the top of the diamond, you want to put whatever a times c is. Now remember, our standard form of a trinomial is ax squared plus bx plus c. So in the top is whatever a times c is, which in this case, we would get a is 1, c is 8, so 1 times 8 would give us 8. In the bottom, you're going to put whatever your b value is. So in this case, our b value, that middle term, is 6. So now, we need to come up with two numbers that multiply to 8 and that add to 6. So in this case, some of the time those two numbers are going to be pretty easy to find. Sometimes you might have to guess and check a little bit, but two numbers that multiply to 8 and add to 6 would be 4 and 2. It doesn't matter what order you put them in. It could be 2 and 4 or 4 and 2. So now we can write out our factored form of this. These are each going to have an x in front of them. Then we're going to have x plus 4 and x plus 2. Now, you can go back and check your work to make sure that you got the right factors here. In order to check your work, you are going to take whatever your two binomials that you ended up with, and you're going to FOIL them. So we get x squared plus 2x plus 4x plus 8. Simplify, combine like terms. X squared plus 6x plus 8, which is the same as right there, so that means this is our answer. X plus 4 times x plus 2. Now let's do another one. So this time I'm not going to draw in the diamond. What we're trying to do, again, remember, since it only has a coefficient of 1, and again, I forgot to read up here, this slide is factoring when b and c are both positive. So that means we're going to have addition in both places here. So really what we're trying to do again is end up with two binomials that in this case, since b and c are both positive, both binomials are going to include addition, and we're going to be adding those two numbers that multiply to our c value and that add to our b value. Again, this changes a little bit if you have a number other than 1 in the front, but for today we only have 1 in the front. So here, we know we're going to end up with two binomials. Since our variable is a, they're both going to start with a. These are both addition, so these will both be addition. Now we need to figure out two numbers that multiply to 15 and add to 8, which in this case would be 3 and 5, and that is our answer. That's our factored form right there. Again, you could go back and check this by foiling those together and making sure you got the right numbers. Let's look at one more here. This one, 9 plus 10t plus t squared. So this one, we actually need to do something before we can start factoring. Because remember, our standard form is always ax squared plus bx plus c. We are always going to write these in descending order in terms of x or whatever our variable is. So that means our squared term always has to come first. So t squared, then we would put 10t plus 9, descending order in order to factor these. So now we can factor it. Again, we know we're going to have two binomials. T is our variable, so that's what they'll start with. These are b and c are both positive, so they will both contain addition. Now, two numbers that multiply to 9 and add to 10. We know that 9 we could use 3 times 3, but if we add those, that gives us 6, so that's not going to work. The only other possibility to multiply to 9 is 9 times 1. 9 plus 1 gives us 10. So we'll have t plus 9 and t plus 1. Again, the order there does not matter. We could have t plus 1 and t plus 9, but since it's multiplication, the order does not matter. So that was when b and c are both positive. Now we're going to get into when b is negative and c is positive. So our first sign is going to be subtraction, then we're going to add our c value. So again, we can go with our x method here. We have a times c in the top, so 1 times 16. We have b in the bottom, which is negative 10. So here, we need to figure out what's going to multiply to 16 and add to negative 10. Now, something to pay attention to here. Since they're going to multiply to a positive number and add to a negative number, that means both of our numbers have to be negative. So two negative numbers that multiply to 16 and add to negative 10 would be -8 and -2. Because when we multiply them, two negatives become a positive. When we add them, a negative plus a negative, so -8 plus -2 is like saying -8 minus 2, which would give us -10. So here, our two binomials, just like before, are going to start with our variable. Then since it's -8 and -2, it'll be x minus 8 and x minus 2. So when b and c were both positive, these both ended up being addition. When b is negative and c is positive, so you have a subtraction and then an addition, these are both going to be subtraction. And again, the reasoning behind that is because they need to multiply to a positive and add to a negative. So this is kind of an easy pattern you can follow as you're going through and doing these problems on your homework. Here, again, we know we're going to start with our variable, which is m. It's a -b and a positive c, meaning they're both going to be subtraction. We need two numbers that multiply to 21 and add to -22. So they're both going to be negative numbers. Now 21, we could have -7 and -3, but those add up to -10, so that doesn't work. Our other option is -21 and -1, which does add to -22. So it'll be m minus 21 times m minus 1. One more here. S squared minus 11s plus 28. So two numbers that multiply to positive 28 and add to -11. In this case, 28 we could do 14 times 2, -14 times -2. That would give us -16, so that's not going to work. We could do -7 times -4. If we add those, it gives us -11, so that does work. So -7 and -4. S minus 7 times S minus 4. Again, if you're not sure if you're doing these right, you can always go back and FOIL in order to check to make sure you got the right answer. So if we FOILed this, we would get S squared minus 4s minus 7s plus 28. Combine our like terms. -4s minus 7s gives us -11s. And as long as your trinomial you end up with here is the same as what you started with, then you're good to go there. So then the third thing here is factoring when b is positive and c is negative. So far we've done b and c both being positive, which ended with two binomials that both included addition. We've done when b is negative and c is positive, which gave us two subtraction binomials. Now we're going to have when c is negative. So here, b could be, I know originally I said b is positive, c is negative, but it could be, b could be positive or negative here. But anytime you see a negative c value, we're going to have one binomial that's addition and one binomial that is subtraction. So in this case, again, we have a times c in the top, b in the bottom. So 1 times -15 is -15, and then we'll have 2 here. So now we need two numbers that multiply to -15 and add to 2. Again, we have our two binomials. One is going to be addition, one is going to be subtraction, because we know the two numbers are going to multiply to a negative, which means one has to be positive and one has to be negative. So in this case, we could do 5 and 3, but we have to figure out which one is going to be positive and which one is going to be negative between the 5 and the 3. The way to tell is by looking at this b value. If it's positive, then the larger number is going to be positive. If this b value is negative, then the larger number will be negative. So since we're using 5 and 3, we're going to use a positive 5 and a negative 3, because 5 plus negative 3 would give us positive 2. If we used negative 5 and positive 3, it would still multiply to negative 15, but that would add to negative 2. So here we're going to have x plus 5 and x minus 3. Let's do a couple more of these. This time, b and c are both negative. So if we do our diamond method here, a times c would be negative 18. Our b value is negative 7. So now, two numbers that multiply to negative 18 and add to negative 7. I'm going to use, let's test 9 and 2 first. So if we do 9 and 2, since our b value, the number that they're adding to, is negative, that means the larger one would need to be our negative number. So negative 9 and positive 2. If we check here, negative 9 times 2 gives us negative 18. Negative 9 plus 2 gives us negative 7. So we are going to have x minus 9 times x plus 2. Two more of these here. Diamond in the top, I'm going to have negative 24. In the bottom, negative 2. So for 24, another way that you can go and do these to try and see what your two numbers are going to be is, say, for 24, you could do 24 times 1, 12 times 2. You could do 8 times 3, 6 times 4. And so you've got all of those different possibilities of two numbers that multiply to 24. We have to see which of those, if we made one of them negative, will multiply to negative 24 and will add to negative 2. So in this case, 24 and 1, those aren't going to add to negative 2 if we make one negative. 12 and 2 won't, 8 and 3 won't. So we're going to have to use 6 and 4. Since our negative, or since what we're adding to is negative, that means the larger number of the two needs to be our negative number. So we would use a positive 4 and a negative 6. R plus 4 times R minus 6. Those multiply to negative 24 and add to negative 2. One more of these. So we have h squared plus 3h minus 40 for this one. So we know two numbers need to multiply to negative 40 and need to add to positive 3. So in this case, negative 40, positive 3. Two numbers that will multiply to negative 40, so a negative and a positive, and add to positive 3, which means that our larger number needs to be the positive number. Now 40, we could do 10 times 4, but neither of those being negative will give us 3. We could do 40 times 1, that's not going to work. 8 and 5, if we do an 8 and a negative 5, add those together and it gives us positive 3. Not x, we have h in this case. So we would say h plus 8 times h minus 5. So those are three different situations for factoring here. Next, solving an equation by factoring. So this is taking what we were just doing, but taking it one step further. So if they tell you just to factor an equation, So if they tell you just to factor an equation, your answer is going to look like this. If they tell you to solve by factoring, then that means you actually have to come up with a solution. But the first thing we would want to do is go ahead and factor. So here, a times c is -6, b is 5. So two numbers that multiply to -6 and add to 5. In this case, that would be -6 and 1. So we would say x minus 6 times x plus 1 is equal to 0. Now to come up with our solutions, we know that since x minus 6 times x plus 1 equals 0, then in order to come up with our solution, we can take x minus 6 and set it equal to 0, and take x plus 1 and set it equal to 0. So take each of your binomials that you factored down to and set them equal to 0, then solve for x. So on the first one, we would add 6 to both sides. We would get x equals 6. Second one, subtract 1 from both sides, and we would get x equals -1. So it's taking what we were just doing, factoring, and just taking it that one step further of solving using those factors. Now, if I come up with one like this, x squared plus 16 minus 28. In this one, I feel like I forgot a variable in there. Yeah, there should be an x with our 16. So x squared plus 16x equals -28. In order to solve this, we have to move whatever is on this side of the equals sign over before we can factor. So in order to do that, we would add 28 to both sides, which would give us x squared plus 16x plus 28 equals 0. Now we can go ahead and factor this. Since these b and c are both positive, we know that both of our binomials are going to start with x plus. Now, two numbers that multiply to 28 and add to 16 would be 14 and 2. Then taking it that one, so that's factoring. Taking it that one step further now is setting each of those equal to 0. So in this case, subtract 14 from both sides would give us x equals -14. On the other one, subtract 2 from both sides would give us x equals -2. So again, if you have anything besides 0 on that right side of the equal sign, you need to move it over so that everything is set equal to 0. Then you're going to factor and set each of those factors equal to 0. Last thing here, a couple story problems. A sponsor for the school yearbook has asked that the length and width of a photo in their ad be increased by the same amount in order to double the area of the photo. If the original photo is 12 centimeters wide and 8 centimeters long, so go ahead and draw a diagram. 12 centimeters wide, 8 centimeters long. What should be the new dimensions of the enlarged photo? So first of all, let's go ahead and figure out what the area of the original photo is, because we know that the area of the enlarged photo needs to be double that area. So area, length times width, 12 times 8 would give us 96 centimeters squared. Now we know that each side needs to be increased by the same amount. So we're going to increase the size of the photo by the same amount. Let's go ahead and call that amount x. So we're increasing the width and the length both by x, and they need to come out to area that is double the original. So 96 times 2, that would give us 192 centimeters squared. So we know we're going to take our original photo, which was 12 by 8. We're going to increase both of those sides by the same amount of x. So I'm going to write that as 12 plus x times 8 plus x, and we're going to set it equal to our new area of 192. So again, 12 plus x, this new length, times 8 plus x, the new width here, is equal to the new area of 192 centimeters squared. So now I'm going to go ahead and FOIL these. 12 times 8 will give me 96 plus 12x plus 8x plus x squared equals 192. So again, in the end, what should the new dimensions of the enlarged photo be? So I need to solve for x here. I'm going to combine my like terms. So 96 plus 20x plus x squared equals 192. Now to solve for x, to be able to factor this, just like on that last slide, I need to have it all set equal to 0. So in order to do that, I need to subtract 192 from both sides. So those will cancel. 96 minus 192 is going to give me negative 96 plus 20x plus x squared equals 0. So I'm closer to getting my answer now. I need to write this in descending order to be able to factor. So I need to have my x squared first, plus 20x minus 96 is equal to 0. Now I can factor this. I need to come up with, using my diamond method, two numbers that multiply to negative 96 and add to 20. So in order to do this, I need to come up with some different possibilities of numbers that multiply to 96. I know I could do 1 times 96, but making one of those negative and adding won't add up to 20. I could go 2 times 48. Again, those won't add up to 20. I could go 3 times 32. If I do 32 plus negative 3, still not 20. I could go 4 times 24. 24 plus negative 4 equals 20, so that will work. So we'll have a positive 24 and a negative 4. So x plus 24 and x minus 4. Now we need to set those both equal to 0. X plus 24 equals 0, and x minus 4 equals 0. So x is negative 24 or 4. Now, only one of these is going to work in this case. If you think of it, since we're talking about increasing a length, we can't increase a length by negative 24 centimeters. So we know that negative 24 will not be our answer. So we're going to say x equals 4. But again, that's not our final answer. It doesn't tell us how much will each side be increased by. It asks us what should the new dimensions be. So in order to find the new dimensions, I need to add both sides, or I need to add 4 to both of my measurements. So if it was originally 12 by 8, it will now be 16 centimeters by 12 centimeters. And to check your answer, you could do 16 times 12 to make sure it gives you your area of 192 centimeters squared. there's your homework assignment for today. Again, this will be up on Schoology for you, the notes, the assignment, everything. Remember, all assignments now should be turned in on Google Classroom. And please continue to feel free to get a hold of me as any questions come up. And just continue going strong down this home stretch. Just about a month left of lessons for this class, and then I'll be communicating with you guys on what we're going to be doing for a final. So yeah, just keep going strong. Reach out if you need any help with this or just need to talk about anything in general.